Good morning class, Sairam. Today we are going to start our next chapter, that is wave optics. In wave optics, the first topic we need to understand, that is wavefront. So understand what is the wavefront. You can say that the front portion of the wave. Okay, in simple language you can say that front portion of the wave is your wavefront. So we can read its definition also. A wavelet is the point of disturbance due to the propagation of light. A wavefront is the locus of the points or wavelets having the same phase of oscillations. So what happens, initially we have one source of light, and from this source of light radiation is coming out in this way, and these radiations actually disturb the medium particle. Okay, the medium that is present, it try to disturb that medium, and if we observe it more clearly, then these medium particle starts oscillations. Okay, they start oscillations. In this way they try to propagate their energy in the forward direction. So a line perpendicular to the wavefront is called ray. If we join all these disturbing elements, then we will say that locus of these elements is your wavelets, is your wavefront, and if we drop a perpendicular to these wavefront, then we will get a kind of ray. Now second definition, or you can understand in this way also, that if we have a line source, then in that case your wavefront is like a cylindrical wavefront, okay, from linear source. And in case of planar wavefront, suppose if light source is placed at infinity, okay, if light source is placed at infinity, then the kind of wavefront we get, that is planar wavefront. Then one important principle to understand wavefront, that is Heisen's construction. So Heisen's principle of secondary wavelets. Now understand, suppose if we have a source of light, and from this source of light this ray is coming out, or you can say the energy is coming out, then this energy comes out in the form of these wavefront, and if we join the wave any particular point on the wavefront, then it says that each point of wavefront acts as a fresh source of disturbance of light. Okay, and the new wavefront at any time later is obtained by taking the forward envelope of all secondary wavelets at that time. If we join all the forward point like this particular line, then this line is called your new wavefront. This definition was given by Heisen. And after that we have laws of reflection. Here you can note down one more thing. He said that backward direction wavefront is not considered. Okay, this because we can see that amplitude is given by, this amplitude of secondary wavelet is given by 1/2 1 plus cos theta, and for backward direction this theta becomes 180. So that's why amplitude becomes 0, means light is not going in backward direction. Now second thing we have, that is called laws of reflection at a plane surface. Okay, we know that for reflection angle I should be equal to angle R, but this thing has been proved with the help of wave theory, or you can say Heisen's principle. In this we consider that one wavefront is falling or incident on this surface in this way, and after that at the surface, at this reflecting surface, you can see this wavefront will reflect from here in such a manner. After that we have mentioned some points over here. Suppose AB is your wavefront, you can see AB is your wavefront that is falling on this reflecting surface, and this A point reach first to the surface. After some time B point will reach up to C, then it will try to reflect. So this angle of incidence is called is this one, that is angle made by incident ray and normal. Okay, and after that we can say that by geometry this angle will also be equal to I. Okay, this angle will also be equal to I, because here we have this angle equal to R. Okay, here you can understand that angle made by normal with the reflected ray, that is R. If this angle is made by this ray is with vertical, then here by geometry we can say that this angle will also be equal to r. In that case we have to determine that if c is the speed of light, okay, and t be the time taken by the light from B to C. Suppose light is going from B to C, then it takes some time t. In that case that time will be equal to how much? That time will be equal to distance upon speed, that is EF upon C, and E to F, try to understand it diagram, E to F distance upon C, and F to G distance from here to here, F to G distance upon C, okay, and this EF will be AF sin I. Here you can see this EF, okay, this EF will be AF sin I, because this will be your right angle triangle, and similarly you can understand this FG will be FC sin R. Now we will try to solve this expression, and finally we are getting that sin I equal to sin R. Okay, so we can say that this is laws of reflection, that is angle of incident should be angle of reflection. The laws of reflection on a plane surface, or you can understand, second we have laws of refraction. We have proved laws of refraction also. In this case, if the c is the speed of light and t be the time taken by the light to go from B to C, and this A to D or E and then G. Suppose this planar wavefront, this wavefront is falling on the surface and light is going from A to D, okay, then F to G, and then from C to forward direction, okay, and this is your denser medium. Here its speed is V and refractive index is mu2, okay. At this point we know that this wavefront is always perpendicular to the incoming waves, or this waves, we can say that this incident ray is perpendicular, and at this point this angle will be angle of refraction R. Basically this angle should be this one R, but this will be 90 minus R, and from triangle we can say this will be R, because all three angles should be 180. Again we can determine time equal to EF upon C plus FG upon V, because here speed has decreased, okay, its speed is V. So EF is again AF sin I and FG will be FC sin R by applying sin theta equal to perpendicular upon hypotenuse. So we can put this value that AF sin I, that will be equal to AF, this will become AF sin R upon V plus AF sin I upon C minus sin R upon B, okay, and after solving all these three equations we will get that sin I upon C equal to sin R upon V, and second definition of mu is mu equal to C upon V. So we can write C upon V equal to mu. Next thing we have to understand that how behavior of concave mirror and then convex mirror and lenses works that with the planar wavefront, okay. So suppose one planar wavefront is coming on a concave mirror. We know that concave mirror forms its image in such a way that at focus, okay, that rays are coming from infinity. So such wavefront we will get that is basically having its radius towards left. In case of convex mirror, we will get a planar wavefront is coming, then we know that image is focused at the center. So such kind of wavefront we will get, that is basically having curvature nature, and its radius is towards right, because image will be formed towards right. And in case of convex lens, the wavefront that is coming from infinity will try to make image at focus. So for that your wavefront should be in such a way that its radius towards right. And similarly in concave lens we can get our wavefront that is expanding in such a way, okay, because image is formed that is virtual. In case of prism we know that if planar light is coming, then it bends, okay, then bending of light will occur, and we can say that your planar wavefront will convert in such a way, because wavefront is perpendicular to the ray, so it will just change its direction. Second thing we have, that is coherent sources. Now coherent sources of light are those sources of light which emit wave, okay, which emit light wave of same wavelength and same frequency in same phase, that are called coherent source. Basically one source of light, if you divide its light in two ways, or you can understand its light is going from a certain direction, then if you make two holes in a particular way, in such a way that light coming from here, that is different and that looks different, and from here that looks different, like they are coming from two light source, but actually their source is similar one, then such light will called coherent sources, in which wavelength will be same, frequency same phase, because their source is same. Now we have how coherent source can be produced by division of wavefront. As I told you in the previous one, you will learn this in Young's double slit experiment, Fresnel biprism also. Then second method we have, that is by division of amplitude, partial reflection and refraction. Second we have interference of waves. When two waves are moving in such a way and they collide, or you can say they interfere into each other, then we call that interference takes place. In interference, basically your amplitude is added, like amplitude of first wave plus amplitude of second wave, both are added to get amplitude of resultant wave. And here we have theory of interference of wave. Suppose one wave is having amplitude E1 and it can be given by A1 sin omega t, and second wave is having amplitude E2, that is given by B sin omega t plus phi. Then we know that by superposition both rays will be added, y1 plus y2 and this plus this. We know sin omega t, sin A plus B is sin into cos B plus cos into sin B. If we will take sin omega t common, we will get this expression A plus B cos phi sin omega t plus B sin phi cos omega t. Now we have to put this A plus B cos phi equal to A cos theta, a new variable, and V sin phi equal to A sin theta, again a new variable. Okay, then we will get our resultant amplitude in this form. Now here we need to determine, one is theta and second is resultant amplitude. For that we will go for Phasor diagram. Here you can understand, like A cos theta will represent one side of the phasor, and B sin phi, this first is A, second is B, okay, and this is A sin theta, and their resultant we can determine by taking Pythagoras or by applying law of parallelogram, that is A square plus B square plus 2AB cos phi, because the two vectors we are representing A and B and their angle is phi degree. Okay, and here then tan theta we can also determine that resultant making angle with horizontal, that will be B sin phi upon A plus B cos phi. Now intensity of any resulting wave, we know that is proportional to A square, and amplitude we got that was A square plus B square plus 2AB cos phi by law of parallelogram. Now next is where the construction interference of wave will take place. Okay, for constructive interference, that intensity should be maximum. Now we know expression for intensity is this one. So when intensity will be max, when cos theta is maximum, and for cos theta to be maximum, your theta should be 2n pi, and if theta is 2n pi or phi is 2n phi, then n should be an integer, positive integer, or you can say 0, 1, 2, 3 like that, because cos 0 is also positive 1. Corresponding to that we can calculate part difference, and part difference is given by lambda upon 2 pi into 2n pi. So we will get part difference equal to n lambda. Now we have conditions for destructive interference. We know that minimum intensity will occur when cos phi is -1 in this expression, and for that phi should be 2n plus 1 into pi, means either it should be 90 degree or it should be 270 degree. For that n should be 0, 1, 2, 3 etc. Corresponding to that we can calculate part difference. Okay, this is the formula for part difference, that phase difference is 2 pi by lambda into delta x part difference. From here we can get delta x equal to delta phi into lambda upon 2 pi. The same thing is it is applying lambda upon 2 pi into delta phi, and condition of delta phi we have got from here 2n plus 1 pi. In next slide you can see that we have comparison of intensities. Maximum intensity we got, that is proportional to A plus B whole square, and minimum intensity we got, that is A minus B whole square. So their ratio will be I maximum upon I minimum equal to a plus b whole square upon a minus b whole square. You can simplify in this form also, and otherwise you can leave up to here also. That is also correct. Now here we have relation of intensity and amplitude and wave width, that is width of the slit. That amplitude I is directly proportional to amplitude square, we know. So for two wave it will be a1 square upon a2 square. Also your intensity is proportional to width. If more space is provided, more amount of light will come out. That means more intensity will be there. So I1 upon I2 is W1 upon W2.